Welcome to the Cosmos web tutorial about nuclear receptor ligand screening. Nuclear receptors are an important target in toxicology, in particular when dealing with repeated doses. They are associated with fatty liver. Hence, the workflow is designed for screening potential nuclear receptor ligands. Our modeling approach is based on activity data from Campbell and ligand-protein interaction data from the Protein Data Bank. These have been selected for all relevant nuclear receptors. Ligands have been identified based on combinations of structural and physicochemical features for each nuclear receptor. Below we see an example of the retinoic acid receptor. We see physicochemical informations like how many rotational bonds there are or what's the molecular weight, which kind of describes the applicability domain or the physicochemical properties of ligands or potential ligands. Furthermore, these compounds need to have certain structural features which are expressed with smarts codes or with visualization of smarts codes on the right side. Principally, we have done this approach for a variety of nuclear receptors, and the compilation of all those little sub-workflows we can see here. So every color represents a nuclear receptor or a compilation of very similar nuclear receptors. Here, for example, we see a retinoic acid receptor and the retinoid X receptor. Or here we can see the LXR, the liver X receptor. So let's have a look on the NIME web portal how to use this workflow. First, we need to log in. Therefore, of course, you need to be registered. There's a link below which explains how to register. So, after putting in your username and your password, you click on Login. And you look for the workflow. It's in Public, Nuclear Receptor Binding, Nuclear Receptor Ligand Screening, and here, this is the actual workflow. We just click on Start. So, principally, we can input a file. So if we want to run a batch of smiles, we can draw a structure from a compound. So let's start with the second one. So we just draw a structure of interest. And this compound should be picked up by certain nuclear receptor predictions. So this is our report. Here we see our abbreviations. So here we see the LXR means liver X receptor, and the VDR means vitamin D receptor, and so forth. And here we see our compound I just entered, and we see it's a potential ligand for retinoic acid receptor, retinoid X receptor, and the PPAR, which has, by the way, a little sub-workflow for fatty acids and retinoids, which have a certain potential for binding. So probably not relevant for when drawing a structure, but here we can download the report, for example, as PDF. So more relevant would be uploading a CSV file with smiles, so a whole batch of compounds. The data needs to be in the following structure. So I've prepared a file with some actives and some non-actives. And we just press next. And here we see again the report. So the web portal version only shows us the active compounds. So the file contained 15 compounds, but only a few are active, for example for retinoids, or this steroid compound. The desktop version gives you a complete output and shows you which compounds are inactive. However, you can get a printout if you click here on PDF. On Cosmos Base you find information about how the workflow was developed and how its performance is. And of course all necessary links are provided in the description below this video. Thanks for watching.